Trigonometric identities. There are three trigonometric identities basically. So the first one is sine square theta plus cos square theta is equal to 1. This is the first trigonometric identity and the most basic one. This you can prove also very easily. What is sine theta? Sine theta is perpendicular upon hypotenuse whole square, plus what is cos theta? Base upon hypotenuse whole square. So this comes out to be p square plus b square upon h square. P square plus b square is hypotenuse square, is upon hypotenuse square. Cancelling this we get 1. So this identity is proven. Okay. So now time for the second identity. Second identity, we can basically take this first identity and divide it by sine square theta. If we divide completely by sine square theta, then we get sine square theta plus cos square theta upon sine square theta, and on the right hand side 1 upon sine square theta. So sine square theta gets cancelled out to obtain 1. Cos square theta upon sine square theta, cos upon sine is cot, it becomes cot square theta, and 1 by sine is cosecant, so it becomes cosecant square theta. So the second identity comes out to be 1 plus cot square theta is equal to cosecant square theta. Now for the third identity, what we can do is take this first identity again, and instead of dividing it by sine square theta, we can divide it by cos square theta. So if we divide it by cos square theta, then we get sine square theta upon cos square theta, that is tan square theta. Cos square theta gets cancelled out, and 1 by cos square theta is secant square theta. Okay. So the third identity comes out to be 1 plus tan square theta is equal to secant square theta. Now many a times in the questions, this directly is not used. That is sine square theta plus cos square theta is equal to 1. Many a times it will be used, but many a times not. So we can just reshuffle it and we can say that cos square theta is equal to 1 minus sine square theta. We have just taken sine square theta to the right hand side, and cos theta comes out to be by taking the square root of this whole equation. Cos theta is equal to root of 1 minus sine square theta. This comes helpful in many places. And also tan theta can be written in terms of sine theta completely. These types of questions are also very common. Tan theta is what? Basically sine theta upon cos theta, and sine theta and cos theta can be written in terms of sine theta by this equation. So we can just directly replace it. So tan theta is equal to sine theta divided by root of 1 minus sine square theta. Okay. So in this identities, there are generally the question of proving. So the first question, let's take a look at that. Prove that, I'll be writing it as P dot T secant A into 1 minus sin A into secant A plus tan A equal to 1. This is the first question. So okay, let's start with left hand side. Many times the questions can be solved if we replace tan, cot, secant and cosecant in terms of sine and cos. Since all these four trigonometric ratios can be written in terms of sine and cos, it becomes a lot easier. For instance, in this question, secant A can be written as 1 by cos A. 1 minus sin A remains the same. Secant A again 1 by cos A, and tan A as sin A upon cos A. So what we have done is, we will be taking this bracket. We have taken cos A as a common in denominator, and it becomes 1 plus sin A. So 1 by cos A into 1 minus sin A into 1 plus sin A upon cos A. We can say 1 minus sin A, 1 plus sin A. This identity a square minus b square equal to a plus b, a minus b. This is also used many a time, so keep it in mind. Okay. So this identity can be used in the numerator, which comes out to be, if we take a as 1 and b as sin A, it comes out to 1 minus sine square A divided by cos square A. This cos A into this cos A. So it becomes cos square A. 1 minus sine square A is equal to cos square A. From the identity sine square A plus cos square A equal to 1. So cancelling this we get 1, which is equal to the right hand side that we have to prove. So equal to right hand side, hence proved. Now second question is cot A minus cos A divided by cot A plus cos A equal to cosecant A minus 1 plus upon cosecant A plus 1. In this we can see that the right hand side also contain an expression and left hand side also has an expression. So we can just convert right hand side and left hand side into sine and cos separately, or else directly also we can achieve the answer. Let's see. So cot A in terms of cos and sine, that is cos upon sine minus cos A, and then cot A again cos upon sine plus cos A. Okay, so taking this cos A common, both are in the numerator, we can take it common, and what we are left with 1 upon sine A minus 1, and in the denominator also we can take cos A common, and what we are left with 1 upon sine A plus 1. So 1 upon sine A is basically cosecant A. So cosecant A minus 1 upon cosecant A plus 1, which is equal to right hand side, that is cosecant A minus 1 upon cosecant A plus 1. This is the question where we can achieve directly. If not, we can simply convert right hand side also in terms of cos and sine, and then we can see most of the time the answer we get is the same for the left hand side and the right hand side. Hence they can be proven that ways also. Next question. Sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1 is equal to 1 upon secant theta minus tan theta using 1 plus tan square theta equal to secant square theta. We need to prove this expression as equal with the help of this identity. We cannot use here sin square theta plus cos square theta equal to 1. So what we can do it, we can just convert this side into tan and secant, because this side is already in tan and secant, we do not need to use anything. So sine can be converted into tan, or secant it can be converted into tan, because sine divided by cos is tan. Cos can be converted into tan and secant divided by cos 1. Same. 1 can be converted into secant if we divide it by cos theta. Okay. So dividing this numerator and denominator both by cos theta, we get this equation. Now this becomes tan theta. Next this becomes minus 1, and this becomes secant theta. And in the denominator also this becomes tan theta, this becomes 1, and this becomes secant theta. So this is the expression that we have got. Now we can see here that this is the expression in which tan and secant we can separate it like tan theta plus secant theta minus 1 divided by tan theta minus secant theta plus 1. We can just do this. Now if we multiply and divide it by tan theta minus secant theta, what? Tan theta minus secant theta, we can see this is how we multiply, and so we can just put this in one bracket and then we can directly multiply. What we get is tan theta plus secant theta into tan theta minus secant theta, a square minus b square is equal to a plus b, a minus b. This is a plus b, a minus b. So we get tan square theta minus secant square theta minus 1 into this expression minus tan theta minus secant theta. And in the denominator, tan theta minus secant theta into this tan theta minus secant theta gives us tan theta minus secant theta whole square plus 1 plus tan theta minus secant theta. Now What is tan square theta minus secant square theta? It is minus 1 because 1 plus tan square theta is equal to secant square theta. So rearranging, secant square theta minus tan square theta is 1. And if we multiply it by minus 1 on both the sides, we get tan square theta minus secant square theta is equal to minus 1. So we can replace it by minus 1. This minus goes into the bracket, minus tan theta minus plus secant theta, and in the denominator we can just take tan theta minus secant theta as common and tan theta minus secant theta plus 1. This is the same expression as we have here in the denominator. Okay, so we can take minus 1 common out of here. If we take minus 1 common out of here, we get 1 minus plus tan theta, here minus secant theta, which is the same expression as this one. So we can directly cancel it out. What we are left with, minus 1 upon tan theta minus secant theta. Taking minus 1 into the denominator, we get 1 upon secant theta minus tan theta, which is equal to right hand side, hence proved. Now next question. Evaluate 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. We need to evaluate. We do not need to prove. Evaluate, most of the time when there are the questions of evaluation, we mostly get an integer as an answer. So let's see what we will get. We will directly multiply the two brackets. First 1 into 1 into cot theta, 1 into minus cosecant theta. Next tan theta into 1, tan theta into cot theta, tan theta cot theta, tan theta into minus cosecant theta, minus tan theta cosecant theta. Next secant theta into 1, secant theta into cot theta, secant theta cot theta, secant theta into minus cosecant theta, minus secant theta cosecant theta. Now let us convert all these into sine and cos. So cot 1 remains same, cot cos upon sine, cosecant 1 by sine, tan sine by cos, tan sine by cos, cot cos by sine, tan sine by cos, cosecant 1 by sine, secant 1 by cos, secant 1 by cos again, cot cos by sine, secant 1 by cos, cosecant 1 by sine. So in this we can directly cancel this one, this. Okay, the values, same values in numerator and denominator can be cancelled. Okay, so what we are left with, 1 cos upon sine minus sine 1 upon sine plus sine upon cos plus 1, because these are cancelled, minus 1 by cos plus 1 by cos plus 1 by cos, 1 by sine, sorry, cos is cancelled, and last 1 by cos into sine. Okay, so these 1 plus 1 can be added together. Minus 1 by sine theta plus 1 by sine theta cancelled, minus 1 by cos theta plus 1 by cos theta cancels. So we are left with these 4 terms, 2 plus cos by sine plus sine by cos minus 1 by cos sine is equal to 2, and we can take directly that 1 upon sine theta cos theta as in the denominator, and so sine theta cos theta divided by sine theta leaves us with cos theta into cos theta cos square theta. Similarly, sine theta cos theta divided by cos theta gives us sine theta into sine theta gives us sine square theta. So cos square theta plus sine square theta equal to 1. Okay, so now here we have plus 1 upon sine theta cos theta minus 1 upon cos theta sine theta. These are the same, so we can directly cancel it out. So what we are left with, 2. This is the answer that we get after evaluating the expression. This was the initial expression. So what we have done, we have directly multiplied the brackets, then we have converted everything into sine and cos, then we have just cancelled the common terms. We have taken the LCM and again cancelled, and then we are left with finally 2 as an answer. Next question. Prove that cosecant theta minus cot theta whole square is equal to 1 minus cos theta upon 1 plus cos theta. Okay, so this is the, sorry, I have forgotten to write 2 here. Cosecant theta minus cot theta whole square, a minus b whole square gives us a square plus b square minus 2ab. So cosecant theta is a, cot theta is b, cosecant square theta, cot square theta minus 2ab cosecant theta cos theta, cot theta, sorry. So cosecant square theta can be written as 1 plus cot square theta. This is the identity. Okay, cot remains the same and this can be written as same. Okay, so what we get, cot square theta plus cot square theta gives us 2 cot square theta. Rest everything remains the same. Now let us convert this expression into sine and cos. So 1 plus 2 cos square theta divided by sine square theta minus 2 1 by sine theta into cos theta upon sine theta. So we are taking the denominator LCM as sine square theta. We can say sine square theta divided by 1 is sine square theta into 1 is sine square theta. Sine square theta divided by sine square theta is 1 into 2 cos square theta is 2 cos square theta. Sine square theta divided by sine square theta is 1 into 2 cos theta gives us minus 2 cos theta only. Sine square theta plus 2 cos square theta minus 2 cos theta divided by sine square theta. Now, can I split it as cos square theta plus cos square theta? Right? So, 1 cos square theta plus sine square theta gives us 1 plus cos square theta minus 2 cos theta divided by sine square theta. Okay? So, now, if we look carefully, we take A as 1 and B as cos theta. Then can we put it into the identity of a minus b whole square? Right? So we can say a is 1, b is cos theta. So 1 square 1, b square cos square theta minus 2ab minus 2 into 1 into cos theta. Okay, so it gives us 1 minus cos theta whole square divided by sine square theta can be written as 1 minus cos square theta. Now 1 minus cos theta whole square can be written as 1 minus cos theta into 1 minus cos theta, and 1 minus cos square theta can be written as 1 plus cos theta into 1 minus cos theta by the identity of a square minus b square, which is a plus b into a minus b. So cancelling this, we are left with 1 minus cos theta upon 1 plus cos theta, which is the right hand side that needs to be proven. Hence this question is also done. Okay. Now, next question is cos A upon 1 plus sin A plus 1 plus sin A upon cos A is equal to 2 secant A. This, I'll give you a hint, simple hint. Take the denominator, take the LCM and just simply solve the equation. You will get the answer very easily. Next question is tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta is equal to 1 plus secant theta up into cosecant theta. Okay, so left hand side, let's start with left hand side. What we will do, we will convert tan cot into sine and cosine. So first is tan sine theta upon cos theta, cot cos theta upon sine theta, cot again cos theta upon sine theta, tan sine theta upon cos theta. So we'll take sine theta in LCM here and here cos theta into LCM. So we will get this in the denominator, sine theta minus cos theta upon sine theta, and in this term cos theta minus sine theta upon cos theta. Okay, so now we'll just multiply What is this? A upon B divided by C upon D. How it can be written? A upon B into D upon C. So here we will be doing the same. So sin theta upon cos theta divided by sin theta minus cos theta into sin theta, which becomes sin square theta. And same is here, it becomes cos square theta upon sin theta into cos theta minus sin theta. Now we can take this common, just changing in multiplying it by -1, we can take it common. So 1 divided by sin theta minus cos theta can be taken as common, which leaves us with sin cube theta minus cos cube theta divided by cos theta sin theta. What we have done is we have taken 1 by sin theta minus cos theta common, as well as we have taken the LCM of cos theta and sin theta. Okay, so here we can use the identity of a cube minus b cube, that is a square plus b square plus ab into a minus b. So what we are left with, this remains as it is. Here a is sin theta, b is cos theta. So a minus b sin theta minus cos theta into the denominator here remains the same into a square plus b square plus ab, that is sin square theta plus cos square theta plus sin theta cos theta. This can be directly cancelled. Sin square theta plus cos square theta is equal to 1. So what we are left with? 1 plus sin theta cos theta divided by sin theta cos theta. So if we take this into consideration, we are left with cosecant theta into secant theta, and this can be cancelled if we split this into 2 terms. Okay, so we are left with 1 plus secant theta cosecant theta, which is the right hand side that needs to be proven. Next question. 1 plus secant a divided by secant a is equal to sin square a divided by 1 minus cos a. So left hand side, let's start. 1 plus secant a, that is 1 by cos a, divided by secant a, that is 1 by cos a. Same what we will be doing here. We will take the LCM in the numerator first, that is cos a plus 1 divided by cos a, and so this cos a and cos a gets cancelled again by this term. If this is the expression, then b and d can be directly cancelled out, and a and c also can be directly cancelled out. Okay, so this leaves us with 1 plus cos a. So if we multiply and divide it by 1 minus cos a, okay, 1 minus cos a, then in the numerator we are left with sin square a. How? 1 plus cos a into 1 minus cos a gives us 1 minus cos square a, which is equal to sin square a, and in the denominator we are left with 1 minus cos a, which is what we have to prove, like here. Okay, so it is sin square a divided by 1 minus cos a, which is the right hand side that needs to be proven. Next question. Cos a minus sin a plus 1 upon cos a plus sin a minus 1 is equal to cosecant a plus cot a. Using this identity, 1 plus cot square a equal to cosecant square a. Here it is of no use to convert it into sin and cos. What we can do it, we can convert it into cot and cosecant. So right hand side expression is already into cot and cosecant, so we need to convert the left hand side. Left hand side, how it can be converted? How can cos be converted? By dividing it by sin. We get cos by sin as cot. Sin divided by sin 1, 1 divided by sin cosecant. So we can multiply and divide it by sin a, which will give the left hand side into cos, cosecant and cot a. Then we can just reshuffle and solve, and we will be able to answer this question. Next is prove that root of 1 plus sin a divided by 1 minus sin a equal to secant a plus tan a. So in this question, the first way is to remove the root. So how we can remove the root? We can directly rationalize it. How we can rationalize it? Just look at the denominator And C, we can multiply and divide it by 1 plus sin A. So what we will be getting? This is the expression that we'll be getting. Multiplying the initial root by 1 plus sin A by 1 plus sin A. So if we convert this numerator, if we see this numerator, we get 1 plus sin A whole square. And in the denominator, we see 1 minus sin A into 1 plus sin A. We can see that A minus B, A plus B, which gives us A square minus B square. That is 1 minus sin square A. So 1 plus sin A root can be directly removed from the numerator. And in the denominator, we have 1 minus sin square A, which is equal to cos square A. So root also can be directly removed. So we are left with 1 plus sin A divided by cos A. If we split the term and we get 1 by cos A, that is secant A, and we get sin by cos A, that is tan A, which is the right hand side that needs to be proven. Next question is that we need to prove sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta is equal to tan theta. So left hand side is already in sin and cos. We do not need to convert it. We can take sin theta common from the numerator. We are left with 1 minus 2 sin square theta. Okay, and in the denominator we can take cos theta as common. Cos theta, we are left with 2 cos square theta minus 1. Okay, so this can be written as tan theta sin upon cos. So here 1 minus 2 sin square theta divided by 2 cos square theta minus 1. We can convert sin square theta into the terms of cos square theta by writing it as sin square theta is equal to 1 minus cos square theta. We can solve this part, this bracket, 1 minus 2 plus 2 cos square theta. So 2 cos square theta minus 1 will be left, and we can directly cancel it out, and we are left with only tan theta, which is right hand side that needs to be proven. Next question is sin theta plus cosecant theta whole square plus cos theta plus secant theta whole square is equal to 7 plus tan square theta plus cot square theta. This you can try it by yourself. It is a really simple question. Just apply the identity of a plus b whole square is equal to a square plus b square plus 2ab, and then you can simply use the 3 identities that we have done, trigonometric identities, and you will be able to reach the answer very easily. Next question is cosecant theta minus sin theta into secant theta minus cos theta is equal to 1 divided by tan theta plus cot theta. So what we can do is we can directly convert the left hand side into sin and cos first. Cosecant as 1 by sin theta will be remain the same. Secant theta as 1 by cos theta, and cos theta will remain the same. We can take LCM of sin theta in this bracket, and in this bracket we can take the LCM of cos theta. We are left with 1 minus sin square theta divided by sin theta into 1 minus cos square theta divided by cos theta. 1 minus sin square theta is cos square theta, and 1 minus cos square theta is sin square theta. So we are left with, by cutting, we are left with cos theta and sin theta. Now this is not the left hand side is not equal to right hand side. So let's take now right hand side. Let's convert right hand side also into the terms of sin and cos. So 1 divided by sin theta upon cos theta for tan theta, and for cot theta cos theta upon sin theta. We will take the LCM in denominator of the denominator. So what we are left with, 1 divided by sin square theta plus cos square theta upon sin theta cos theta. So if we apply this, suppose this is given, then what does it becomes? C divided by B. So here sin square theta plus cos square theta is equal to 1. Sin theta and cos theta will go into the numerator, and we get this as right hand side, which is equal to the left hand side that we got before. So right hand side is equal to left hand side, hence this question is also done. Now next question is 1 plus tan square theta upon 1 plus cot square theta equal to 1 minus tan theta upon 1 plus minus cot theta whole square is equal to tan square theta. So this is 3 terms are given here. So we can directly prove this equal to this, or this equal to this, or we can prove this equal to this equal to this equal to this, and this equal to this any time. Okay, we just need to prove any. So first we will be taking this and this one. It is very easy to prove, so try it by yourself. And then we can take these two. This is also very easy, so it can be done by yourself. Okay, thank you. This ends the 4th part, and the next part for the trigonometry will be some extra questions only.